Welcome to TI Precision Labs. In this series, we're going to discuss USB battery charging specification revision 1.2, or USB BC 1.2. We'll go over the basics of the USB battery charging modes and what they look like on the USB data lines. Many TI devices, like USB hub controllers and redrivers, support various USB battery charging modes. This presentation will help determine the right mode for your application. Anyone that owns a phone or a tablet has likely used charging over USB. Since USB ports were common on almost all computers, they became the obvious choice for connecting devices to exchange data and charge batteries. Now, USB ports are also found on AC adapters and in cars, even integrated into electrical wall outlets. The USB BC 1.2 specification was developed as a way for the device to determine how much current it is allowed to draw from the USB port and ensure users have an acceptable charging experience. A USB 2.0 connection consists of a V-bus, typically 5 to 5.5 volts, the data lines, DP and DM, and the ground. First, let's discuss some common terms used when talking about USB BC 1.2. Portable device, or PD, is any device that can draw charging current and connect or enumerate on USB 2.0. Standard downstream port, or SDP, is a port on a USB host or hub that allows a PD to enumerate on USB 2.0, but not draw more current than the typical USB specification current, which is 500 milliamps for USB 2.0. Charging downstream port, or CDP, is a port on a USB host or hub that both allows a PD to enumerate on USB 2.0 and draw up to 1.5 amps of charging current. A dedicated charging port, or DCP, is a port typically on an AC adapter that allows a PD to draw charging current up to 1.5 amps, but no USB 2.0 enumeration occurs. So how does a PD determine how much current it can draw from a port? First, when there is a physical connection made between the PD and a port, it is considered attached, and the PD monitors V-bus. The PD will detect V-bus when it is above a threshold of at least 800 millivolts up to 4 volts. Second, it goes into data contact detect to determine that the DP and DM lines are valid. Third, the PD starts port detection. Primary detection detects between SDP and DCP-CDP modes. Secondary detection, if implemented, detects between DCP and CDP modes. The port detection steps are described in more detail next. In primary detection, the PD puts a voltage source of 500 to 700 millivolts on DP, enables a current sync on DM, and then monitors the voltage on DM. If the PD is attached to an SDP, which incorporates the standard downstream pull-downs of 15 kiloohms on the DP and DM lines, the PD will detect the voltage on DM is lower than the voltage source applied to DP. The PD will determine it is connected to a port that can only support up to 500 milliamps of current during USB 2.0 operation. No extra charging current can be drawn. As shown on the left-hand side of the scope plot, if the PD is connected to a SDP, the voltage on DM will be lower than DP. Secondary detection does not occur. If the PD is attached to a DCP, which shorts the DP and DM lines through a 200 ohm or less resistor, the PD will detect the voltage on DM is close to the voltage source applied to DP. The PD will determine it is connected to a port that can support up to 1.5 amps of charging current. A CDP can behave in either of two ways to generate the voltage on DM so the PD can determine it is attached to a charging port. Either it can enable a voltage source on DM whenever the port is disconnected and disable it when the port is connected, shown here in the blue rectangle, or it can enable a sync on DP and compare it with a reference voltage of 250 to 400 millivolts. If DP is greater than that, but less than 800 millivolts to 2 volts, the CDP enables a voltage source on DM, sync shown here in the green rectangle. Once the PD has determined that the voltage on DM is above the voltage reference, the PD is able to draw up to 1.5 amps of charging current. As shown on the left-hand side of this scope plot, If the PD is connected to a charging port, the voltage on DM will be close to the voltage on DP. After completing primary detection, the PD can connect by enabling its pull-up on DP. Or, if the PD is not ready for enumeration, it must start secondary detection. Any PD that is not ready to be enumerated within 1 second after detecting VBus is required to implement secondary detection. Otherwise, it's optional. A PD implements secondary detection to determine if it is connected to a DCP or CDP charging port. The PD disables the voltage source on DP, then outputs a voltage source between 500 and 700 millivolts on DM and enables a current sync on DP. It then compares the voltage on DP to a voltage reference between 250 and 400 millivolts. If DP is higher than the reference, it is connected to a DCP. As shown on the right-hand side of this scope plot, if the PD is connected to a DCP, the voltage on DP will be higher than the internal voltage reference. Then, the PD will determine it is connected to a DCP, turn off the voltage source on DM, and enable a voltage source or pull-up on DP. The PD can safely draw up to 1.5 amps of current from VBus. In this case, when the PD outputs a voltage source between 500 and 700 millivolts on DM, enables a current sync on DP for secondary detection, and compares the voltage on DP to a voltage reference between 250 and 400 millivolts, DP is lower than the reference since it is connected to a CDP. As shown on the right-hand side of this scope plot, if the PD is connected to a CDP, which does not short the DP and DM lines, the voltage on DP will be lower than the voltage reference. The PD will determine it is connected to a CDP, disable the voltage source, and leave both DP and DM low until it is ready to be enumerated. Once it is ready, it will enable a pull-up on DP to connect. The PD can safely draw up to 1.5 amps of current from VBus. In summary, the USB BC 1.2 specification defines straightforward and easily checked signaling between the portable device and the port that discloses how much charging current is available. Thank you for joining us. And if you have any questions about USB battery charging 1.2 or USB, visit our engineer support forums at e2e.ti.com and look for us in the interface section. If you're interested in learning about USB layout basics, please check out this presentation on our TIPL series.